Hey rock buddies, it's Papa. Glad to be talking to you today on this beautiful spring day. And I just wanted to say that if you want to email me with a question or a comment, I'd love to get an email from you. Anand from India, email me about your rock. And you guys email me about any kind of rocks or questions or comments or whatever you have at acromonicon@gmail.com. That's all lowercase, ACROMONICAN @gmail.com. Okay, super. In this geologic history of Georgia and the eastern United States, we have talked about a lot of major tectonic events. We started with the rifting of Rodinia back in the Precambrian between about 750 and 550 million years ago. We talked about the Cambrian explosion of life and the rift-to-drift sequence that you get whenever a supercontinent breaks up. Then we talked about the tectonic mountain building event, the Acadian Orogeny, and how it affected the East Coast from about North Carolina, from about Virginia north. It had an interesting effect. It had a crashing effect from North Carolina south. There was no crashing. There was island arc formation, but no crashing. Then we talked about the Acadian Orogeny, which happened during Devonian times. That'd be about 400 million years to 350 million years ago. And in Georgia, that's when all the crashing and smashing, a tremendous amount of smashing and crashing occurred. And then finally, we talked about the Allegheny Orogeny, which happened during the Pennsylvanian and Permian time. And that's when Africa smashed onto the North American continent, creating a lot of folding and faulting and metamorphism in the rocks, all the way through the ridge and valley, or valley and ridge province. Created a bunch of coal deposits all up and down the eastern United States and really all over the world that became the world's most important coal deposits. And now we have just one more huge tectonic event to talk about, and that's the rifting of Pangaea. Pangaea was the last supercontinent we had that was put together by all these several crashing and smashing events I've just mentioned. But things don't stay stable too long in the world of tectonics. And so even as Africa was smashing into the North American continent in the east, rifting was beginning. And the first thing I want to show you is the rocks that were created in Georgia, that we can find in Georgia from this rifting events. That would be diabase. Diabase dikes is what they're called. Let me show them to you. I think I've already showed you these to you once, but you see all these lines, very slender lines on the geologic map. They all run from northwest to southeast. That's completely different from the trend of most of the rocks, the northeast to southwest trend of most of the rocks. These are diabase dikes. Diabase is a mafic magma lava, magma mostly, and it's intermediate between gabbro and basalt in its crystal size, but it's made out of the same minerals as both gabbro and basalt lava. These dikes were the blowtorches that helped rift Pangaea apart, and they are all oriented at 90-degree angles to the main rift. The main rift did go northeast to southwest. And so these diabase dikes, like I said, were the blowtorches, and they're located all up and down the eastern United States. Let's just stop right here and take a look at diabase itself, because it's a pretty cool rock. This is a piece of diabase. And, you know, most of the rocks that we find in the Eastern Blue Ridge, Western Blue Ridge, and the Piedmont are metamorphic rocks. But diabase is a rock, is an igneous rock that we find in these provinces, mostly in the Carolina Train and in the inner Piedmont zones. It is a mafic rock. It has pyroxene in it, maybe some hornblende, and it has calcium feldspar that's high in a kind of calcium-rich feldspar called anorthosite. You might be able to tell that it's very hard and crystalline in its structure. When you crack this rock with your hammer, it's really hard to crack. And that's a sign that, first of all, it hasn't been mashed and crashed by metamorphism, but also the nature of the minerals in there form this hard crystalline rock. You might also notice that there may be a slightly blue tinge to it, and there are specimens of diabase that have a distinctive bluish tinge to it, and that gave it its other name, another name called bluestone. A lot of people call it bluestone. One of the things that diabase has been used for in the past is American Indians and our European ancestors back in the Paleolithic time, the Stone Age. They made these gorgeous polished hand axes, and diabase was one of the main rocks that they used because it was hard. And once they went through the painstaking process of making it into a hand axe, that looks weird. It would last a long time because of its hardness, and you could put a pretty sharp point on it. Another interesting thing about this bluestone, diabase, bluestone, same thing, and then there's also another name, dolerite. Dolerite is another name. I think it's used primarily in Europe, but if you've ever heard of Stonehenge, who hasn't heard of Stonehenge? There's an original inner circle of stones. I'm not talking about the big stones with the T-shaped tops on them. I'm talking about a circle of smaller stones that's much older. Those stones are, in fact, made of what they call dolerite, but it's the same thing as diabase. And they believe now that this diabase was quarried many miles away from Stonehenge in the province of Wales, which was a Celtic province of southwestern England. And that originally these stones were set up in another location in Wales, and probably by the Neolithic people, the people that brought farming into Europe. And then later on, 400 years later, they were, or plus or minus, they were moved to Stonehenge, and the bigger stones were quarried and put up. The bigger stones, I'm not sure what they're made out of. It's either limestone or granite, but I can't remember. Anyway, that's diabase dikes that did the rifting of Pangaea. Now, how about rift basins? You know, like the Great Smoky Mountains is a rift basin that's associated with the rifting of Rodinia. How can we find rift basins associated with the rifting of Pangaea? Yes, we can. In Georgia and in Alabama, we don't find rift basins on the surface. We find these diabase dikes, but what we do find is deep underground in Georgia and Alabama and maybe other places in the South, we find terrains that belong to Africa, or Gondwana, which is Africa and South America, that came over when Gondwana crashed and stayed here. And they have different names. I'll show them to you. First of all, I need to show you this book. It's a great book. Oops, I gotta flip my thing. Hang on. a super excellent book all about the geology of Alabama. I highly recommend that you get it. I've learned so much from it. Jim Lacefield is the author, and but the pages come out, so be careful with it. Here we have his a drawing that Dr. Lacefield provided in his book. It shows this is a Suwannee terrain. I think I mentioned this earlier. This was a piece of Africa that crashed in, and then when Africa rifted off when Pangaea rifted away and Africa went away, it left this. This is deep underground. And then there's the Wiggins Train in Alabama, which is southeastern Alabama, which is the same thing. It's a hunk of Africa that stayed when Africa rifted apart. And here's a cool picture of what happened. When you have these rifting events, you don't just have one rift. They usually form a 3-part rift. And that's what we had down here. And those rifts are separated by about 120 degree angle, and that's what happened here. One rift, one leg of the rift, the other leg of the rift, and then another leg of the rift, and this is Africa, and it rifted away. So that happened during the rifting of Pangaea. When did this rifting of Pangaea get started? Well, the first huge event that let the prehistoric world know that something was happening associated with the rifting of Pangaea was in the very end of the Permian time. This would have been 250 million years ago, right on the time boundary between the Permian and the Triassic. And they call this event the Great Dying. The reason they call it that is because of what happened during this time. 90% of all sea creatures were wiped out, and 70% of all land creatures were wiped out. That's the bad news. The good news is, if you want to look at it that way, is that this event that virtually destroyed the earth, so much of the earth's habitat, also made way and gave rise to evolution of the dinosaurs who ruled the world during the Jurassic times, Jurassic Park, and also what followed, which was Cretaceous times. What caused this great dying? Well, about 250 million years ago, plus or minus, the most gigantic basalt lava eruption, like the lava, the black lava in Hawaii, the most gigantic basalt lava eruption ever seen, as far as I know, began to occur, and it occurred in Siberia. They call this huge eruption the Siberian Traps. It covered an area that was maybe half the size of the United States, maybe the size of the United States. Massive amounts of basalt lava were erupted over and over again. This massive basalt lava eruption lasted for 2 million years straight. It didn't stop for 2 million years, and what that did was is associated with the rifting of Pangaea. I don't know exactly how it was, but the rifting came so quickly in association with these Siberian traps that it's a smoking gun kind of thing. Anyway, all this volcanic eruption just polluted the skies of the world with sulfur dioxide and carbon dioxide. And that had, as we know, environmental effects that wiped out so many of the creatures of the land. You can look that up and find out more about it, but I want to keep going with this rifting of Pangaea. So that's the first thing that happened. And then during the Triassic time, that would be 250 million years ago to about 200 million years ago, all these rift basins began to develop all up and down the eastern United States. And these rift basins, they didn't result in the ultimate rift, but they were like partial rift basins. Like the Great Smoky Mountains is a rift, Robin, but it wasn't the actual main rift. These rift basins that are up along the eastern United States were associated with the Great Rift, but they were rift basins. Where are they? If you go to New York and you drive along the Palisades Parkway, the Palisades are huge, piles of diabase that was intruded into the earth during the rifting of Pangaea. And what else?
Absolutely.
In Pennsylvania, you have the Newark Basin and the Gettysburg Basins. You can go there and see diabase dikes there. In Maryland and Virginia, you have the Culpeper Basins. In North Carolina, you have the Deep River and Dan River Basins. And these basins all up and down the East Coast contain not only diabase, which was the blowtorch that did the rifting of Pangaea, but also metagrey whack, sandstone, shale, and siltstone. And this was a dry time. Triassic was a dry time, and so these rocks are red and they're brown. And a lot of these rocks have been quarried. I may have mentioned this before. Have been quarried and used for the building of structures all up and down the eastern United States. You've heard of the brownstone mansions in New York City, I guess. And those were made from the brownstones that were associated with these rift basins. Okay, so that's a pretty quick and dirty summary of the rifting of Pangaea. And I hope it'll give you an idea of what went on. After Pangaea rifted, all the continents separated and became the world configuration of continents that we have today. There's still a mid-oceanic ridge erupting basalt lava all up and down the Atlantic Ocean. If you go to Iceland, you can see where it reaches the surface, and you can just watch this mid-Atlantic or mid-ocean ridge, quote-unquote, erupt right on land in Iceland. Or is it Greenland? I think it's Iceland. And these tectonic processes are still happening. I may have mentioned before, India is in the process of crashing into the mainland of China, and that's what's pushed up the Himalaya mountains. Italy is in the process of crashing into mainland Europe. So these processes continue, and I'll have more videos for you on other things, but I think we've completed the rough outline for the geologic history of Georgia and the eastern United States. I hope it's been informative to you, and as I've said before, please make comments. If you would like to say something about the videos, correct me where I'm wrong, please do, and email me with questions, photographs of rocks. I love to help ID rocks for you guys. But mainly I want to say thanks for watching these videos. I really appreciate everybody who does watch them, because it means you're interested in learning and you like rocks. So that makes us the same kind of people. God help you. No, that makes us the same kind of people, and I think that's wonderful. So have a great spring, and Papa out.